In this video, we get some new vocabulary and a theorem. So to differentiate, that's a new verb, that means to calculate the derivative. So if I were to give you a function and say differentiate, I'm telling you to calculate the derivative. That's all it means. And we can turn it into an adjective. We say f of x is differentiable at a point A in its domain if the derivative at A exists, if it's possible to differentiate that function at A. And I just make a note here that we adjust to use a one-sided limit in our definition of the derivative if we're working at an endpoint in the domain. So sometimes functions have a finite endpoint. For example, we'll be looking at f of x equals the square root of x in the next video. And its domain is the interval from 0 to infinity. So when we're talking about whether the function is differentiable at 0, we'd be looking at the limit coming in from the right. This is similar to what we do with continuity. For continuity at finite endpoints, we work with one-sided limits as we approach an endpoint from the interval we're working with. And then theorem 4 actually gives us a connection between a function being differentiable and it being continuous. It says that if the function is differentiable at a point, then it's continuous at that point. Now, a lot of times students get this confused and they think, oh, if it's continuous, it's differentiable, or the two always have to go together, and that's not the case. Being differentiable is a stronger condition than being continuous. It is entirely possible to have a function that is continuous at a point, but is not differentiable at that point. And the classic example of that is f of x equaling the absolute value of x. Okay. If I look at this corner point right here, at the vertex of that v, okay, this function is continuous at 0. Because what it means to be continuous is that the limit as x approaches 0 of the absolute value function is just the absolute value of 0. And that's true. Those are both equal to 0. If I look coming in from the left, I would expect there to be a point right there. Coming in from the right, I expect there to be a point right there. Okay. So the function is continuous there. But it's not going to be differentiable there, because there we've got this sudden change in the behavior. So there's a sudden change in the behavior of the function. That means that the derivative, which describes that behavior, doesn't exist at that point. However, there is not a sudden change in the value. When there's a sudden change in the value, we might have a jump discontinuity, something like that. That's a sudden change that affects the actual value of the function, and that would force the function to not be continuous. But this isn't a sudden change in the value of the function, it's a sudden change in the behavior of the function. So this function, that's our classic example of one that's continuous but not differentiable at a point. Okay, in the next video we're going to talk about ways in which a function can fail to be differentiable. And we're not going to look at every possibility, but we're going to look at some common ways that that can happen.